Um, good morning to everybody. I am Pierluigi Porta from the Italian Agency for New Technologies, Energy and Sustainable Economic Development, INEA. And I work in the Valorization Resource Laboratory in Italy, actually. And I will host this capacity building workshop that is on energy efficiency in schools buildings, tools for energy performance and analysis. So I ask you if you can see, if you can see my screen, just to, yes, perfect. So I will do a brief introduction and welcome. Then Mattia Ricci, a colleague from ENEA, will speak about T-Schools tool. Then Valentina Mattara from province of Treviso will introduce the EduFootprint tool. Then different from the previous agenda, there will be Fabio Brescia introducing a project called Effect. And we will finish this first part with question and answer part. I would like to ask you to type the question in the chat. I will try to sign everything, to write everything, and I will make the question to the speakers in the question and answer part. After this part, there will be a training of the T-School tool made by Mattia Ricci, another part on question and answer on this topic, and at the end with wrap up and conclusions. Before the end, we will give you a form, a brief questionnaire for all the participants. I will I will put the link in the chat for you. So briefly, the Efficient Building Project is a project that is an horizontal project of the Interreg Mediterranean program, and is focused on energy efficiency in public buildings. The consortium is composed by local and public authorities, energy agencies, research institutes, and NGOs. And the objective is the promoting the activities of med-efficient building community in Europe. This project is responsible for the communication and transferring activities of 10 Interreg Med modular projects. We will know two of it today, and to promote it its result in European policy stage, at the European policy stage. So today we have some objectives to reach, we hope so. We want to train the participant, you, with a set of tools to simplify the energy renovation of public school buildings. The objective is to better manage the energy performance of the school buildings. At the same time, better manage the energy performance and helping reducing the environmental footprint of these buildings. This tool that we are going to see are aim at raising the capacity of the owners or the manager of the school building to better manage, plan, and monitor the energy consumption of the buildings. So briefly, I introduced you the two projects. T-School have as final results the web tool that we will see later, a database of best available technique for renovation of school buildings, and an e-learning course on the efficient management of energy in buildings. So these are the outputs of the project, the main output. The scope of the project is measurement and assessment. The target is local decision makers and school building user, and the countries that tested this tool were France, Italy, Greece, Spain, Croatia, and Cyprus. While the EduFootprint project made this the calculator, so the tool, the effective tool for the schools, an app downloadable on mobile phones and tablet for to check the CO2 emissions, and a platform for to exchange best practices. So, sorry. Yeah, of course, the scope is as for this school to measure and assess the impacts. The target is this, both the school owners and the local authorities, and the test, the nations that tested this tool were Spain, Greece, Slovenia, Italy, and Portugal. So I leave the floor now to Mattia Ricci to present this school. Mattia is also a researcher of the Italian Agency for New Technology, Energy, and Sustainable Economic Development. Is an expert in a field of numerical simulation, and it's he has a lot of experience on ranging from structural analysis to building physics and district heating modeling. I leave the floor to Mattia. Thank you for your presentation.
Thank you, Pierluigi. Thank you. I share my screen. Could you please stop sharing yours, Pierluigi? Yeah, perfect. Could you see my presentation?
Yes.
Okay, perfect. So thank you. My name is Mattia Ricci, and I'm a researcher at the Italian Agency for Energy, New Technologies, and Sustainable Economic Development. Today, I'm going to show to present you the web tools implemented for school buildings improvement. Of course, web tools developed in the framework of the T-School project. First of all, we have a glance at what is T-School project about. So T-Schools is a project that aims to transfer energy efficiency in Mediterranean schools and aims to develop an integrated strategy for Mediterranean countries that supports public administrations by providing innovative tools and trainings in energy renovation of public school buildings. This is done in order to promote the construction of nearly zero energy buildings. The project is made up of 11 partners from seven different countries. So Italy, Greece, Spain, Cyprus, Croatia, France, Bosnia, and Enea is the project coordinator. What are the main activities performed in the T-School project? The main activities are an integrated set of tools has been developed in order to perform a pre-audit simplified energy assessment of the buildings. This tool, I'm going to describe this tool later during this presentation. This tool is free, available at the link improveyourschool.enea.it. it. And this tool has been tested and validated in 3 schools of the 7 partner region. And the pilot included the energy audits of representative school buildings, drawing up preliminary renovation plans, calculation of carbon footprint of the renovation activities, development of energy service models and financing schemes. Some theoretical, let me say, theoretical background of this project. The school buildings, indeed, all the other buildings have high energy consumption, in particular for heating, but also for the production of hot domestic water, for lighting, of course, and for other services like mechanical ventilation, cooling, and internal transportation. In this picture, we can see that the buildings are the largest energy consumer, being responsible for the 40% of energy consumed, let me say. Industry is responsible for the 32% and transportation 28%. So regarding the 40% related to buildings, 22% is related to residential buildings, with in which you can see that of this 22%, the 31% of energy is used for heating. Regarding the commercial buildings, the 26% of energy consumption is related to lighting. So it appears that in order to save energy, the most important parameter to look at in residential buildings is the heating. Sometimes, in addition to that, it is important to observe that sometimes energy is not used in the most appropriate way for the final service. In other cases, the system for the production and distribution of energy have low performances, so low efficiency, or the energy use doesn't take place in the best way. For example, high heat losses in distribution net, overheating, high energy losses through windows, and etc. So home and buildings in industrialized countries represent the 40% of energy consumption, the 12% of drinking water consumption, 38% of greenhouse gas emissions, and 40% of solid waste. In all these cases, there is a greater use of resources than necessary, with negative effects on both on the user's comfort and the waste of money. So to help stakeholders interested in school buildings, a web tool has been developed in the framework of this project with the aim to simplify the analysis of the actual state of a school building, and in order to easily understand how to implement energy improvement actions. It is important to highlight that the web tool that has been developed in order to analyze energy performances of school buildings is not a design tool. The design of improvement actions must be entrusted to professionals, so engineers, architects, energy experts, chosen by the school manager. Anyway, the tool gives the possibility to evaluate if it is the case or not to proceed with an energy audit, and then it allows to evaluate what is the intervention that can give the greatest savings in terms of energy consumption, of course. In fact, the tools allows also to assess the weight of every single action in comparison to the total savings. How is the energy performance of the school buildings evaluated? This energy performance is evaluated with respect to the average value of the national school consumption of that specific country. And it allows to identify the simplest intervention that can be made in order to improve the energy quality of the school buildings. And of course, this intervention must be carried out by professionals. In the website that is online, of course, and it is it has been specifically implemented for this tool. There are also other information that can be found So project information, norms and local regulation information, and collection of best practices. The evaluation of the energy quality has been performed in comparison with the representative samples of similar schools. The examples used for the comparison were originated from a series of complex energy audits performed in the different European countries. In the picture on the right, you can see the homepage of improveyourschools.enea.it. So in the tools menu, you can find two items: building performances, state of the art, and building improvement. And you can choose, for example, the country. The web tool evaluation can be applied to different types of schools: preschools, primary and secondary schools. And at the beginning, when you start using the tool, at the beginning, it is asked for the school name and the municipality that is used in order to assess the climatic conditions and the address. In the second part of my presentation, I will show you a brief demonstration in, let me say, real time with my desktop shared in order to show you how the tool is simple and how it works. How is the calculation performed? To determine the energy indicators, there are 6 phases that are performed by the software. The first one is the consumption evaluation. Second one is gross heated volume, gross area of the floors, and dispersing surface of building collection. Then the degree days are evaluated for the city in which the building of the school is located. Energy consumption is normalized depending on the shape of the buildings, in order to compare buildings with the same energy consumption but with different shape factors, of course. The operating time also is a very important factor because it defines the habits and how many hours for a day the building is active, let me say. Finally, the normalized energy indicators are calculated. Regarding the step 1, the consumption evaluation, as a first step, the energy consumption for heating for the last 3 years are collected, and then an average value has been calculated by, of course, dividing by 3 the sum of the 3 years energy consumption. This is done for both heating consumption and electricity. You have the possibility to choose among different sources of energy, so methane gas, diesel, fuel oil, LPG, firewood, coal, and electric energy, of course. The data of an annual consumption of fuel and electricity should be registered in a specific table as shown in this slide. Then the step 2 is the compilation of specific building data, so gross heated volume, dispersing surfaces, and gross floor area. These data are obtained from the drawings if they are available, or the building can be measured from the outside, of course. The gross heated volume, the external walls must be included, and the not heated parts of the building must be excluded, because of course then these parts are not heated. If the school building consists of several buildings, volume will be the sum of the volumes, of course, of individual buildings. The gross floor area is obtained again from the buildings and is the sum of the area of each floors and must be exclude not heated parts. As well as the dispersing surfaces, I mean, that are the basically the surfaces of the heated volumes. The third step regards the degree days of the place in which the school is located. To compare it in consumption, of course, it is necessary to take into account the different climatic condition among different locations, of course. According to this, consumption is released from climatic differences through the use of degree days. that are obtained at the sum of the positive differences between the internal comfort temperature and the outdoor daily average temperature. Summation is extending to all the heating period, so the heating days of the winter season. During the phase 4, the specific consumption of school buildings is normalized with a factor depending on the shape. That is the ratio between the surfaces that are responsible for the heating dispersion and the volume of heated parts. Here we can see, for example, different shape factors for a kindergarten, a primary school, and a secondary high school. During the phase number 5, then the operation time is defined, and a normalization factor related to the operational time is obtained based on the number of hours the school is active for each day, as you can see in the table on the bottom right of this slide. During the step number 6, the normalized energy indicators based on the, of course, aforementioned information is calculated. So the normalized energy index for electricity and the normalized energy index for electricity has been calculated. And the software, the web tool, gives you an indication on how the building is performing. So if it is in terms of energy of consumption. So if it is performing good or bad. The evaluation of the specific consumption is carried out by comparing the specific consumption with those of the reference sample. That is very important because this is a relative comparison. The energy class of the school building is identified according to reference tables that take into account the specific consumption data compared with those from the reference sample. Energy data, of course, average data, of course, comes from the audits. If the normalized energy indicator is sufficient, the school building is associated to an average consumption, and it is advisable to propose improvement sections. If the energy consumption is if the normalized energy indicators value is good, the school building has efficient systems and good management, and no improvement action is necessary. On the other hand, if it is insufficient, it is necessary to identify deep intervention. Then there is another module that has been developed for the web tools in order to assess the effects of different improvement action that can be done. For example, improvement action can be done on the building envelope to reduce heat losses, on the heat production systems for heating and hot domestic water, or more conscious behavior on energy management of school buildings can be implemented. In the second part of the tools menu, you can choose among different improvements in order to evaluate savings. So you can select multiple improvements. For each one, you will get the estimated energy saving and the impact in percentage on the total savings. So you are able to assess which intervention has more weight. In this case, for example, we show that we decided to improve the energy performance of glazing, of roofs, of the roof, of course, walls and floor. And in the right side, you can see that, for example, the 60% of energy savings is due to the walls. Regarding the plants, we decided to, for example, improve the heat generator efficiency and the lights efficiency. And in this case, the 5% of energy savings is due to the lighting. So thank you for your attention. In the second part of my presentation, I will show you in real time how the web tool performs, and of course I am able for questions regarding this tool.
Thank you, Mattia. Just a quick question now, then we will see if there are no questions in the chat yet, but maybe later. Just a quick question. Is it the tool intended for? I mean, is it for a simple user, expert user, or what?
Well, the tool, it is important to underline that the tool has not been developed as a design tool. So you cannot rely on the tool in order to perform quantitative evaluations. But the tool is very useful in order to do a pre-analysis, a preliminary analysis, in order to understand quickly, very quickly, and in a very simple way, in order to understand if the school buildings is if it is necessary or not an intervention in order to improve the energy efficiency of the building. So I think about, for example, also I think that it can be used also by administrative personnel of the school, or the common people, non-professional people in general.
Okay. Thank you. We'll talk later again. And I will introduce Valentina Mattara from province of Treviso. She's a coordinator of the International Relations Office of the province of Treviso, and she carries out very old project. She's a project manager different. She has been project manager of different EU programs. Now she carries out activities on for the province of Treviso, and she will. I am leaving you the floor.
Thank you. Thank you very much, Pierluigi. First of all, I'd like to thank you for the invitation to participate in this capacity building workshop. My task today is to present the results of the EduFootprint project and the products that have been created in the frame of the same project. I'm going to share my presentation. And so, can you see?
Yes.
Full screen? Okay, perfect.
Yes, perfect.
Okay. I give you a brief overview of the project. The project started at the end of 2016 and ended in May 2019. The allocated budget was more than 1,200,000 euros, and was one of the 10 modular projects dealing with the energy efficiency, and collaborated in the thematic community efficient buildings created in the frame of MED program. These are the partners who collaborated, and the province of Treviso was the coordinator of the project. We had also among our partners also a partner coming from Albania. The purpose of the EduFootprint project was to focus on improving planning and energy management in school buildings with a life cycle assessment approach, analyzing the environmental footprint as a result not only of the direct impacts of energy consumption, but also of the indirect ones coming from energy-related activities, such as public procurement or general awareness or behavior. Why it is important to calculate the environmental footprint? This was the starting question of our project. The reasons, as you know, are different. The control of the impacts related to the consumption of resources, the adoption of those solutions that allow a more efficient use of resources, obtaining possible economic and social benefits. But a step ahead, why calculating the environmental footprint with a life cycle assessment approach? Because this permits assessing environmental impacts associated with all the stages of goods or services life, which is from the raw material extraction through materials processing, manufacture, distribution, and use, to evaluate and calculate the entire life cycle of the products and services. And which was the unit we decided to take into consideration? The unit was the student attending the school in a specific school year. And this is the frame where with our discussion and our experimentation took part. Between the direct services and the indirect ones, we find the teaching, education, and training system. And all that is linked to the system, to this system, from the direct services such as the technological one, heating, cooling, and so on, lunchrooms, meals, caterings, lab devices, operating and maintenance cleaning, towards indirect services, mobility, procurement, and waste management. EduFootprint was a testing project and it involved 7 pilot areas from Italy and Spain, Greece, Albania, and involved 62 school buildings from kindergartens to university, and 22 SEP municipalities and 1 union of SEP municipalities. And the main actors of the project were different, were the owners and managers of buildings. It depended on the system of each country, because sometimes the owners is different from the manager of the school building, the schools themselves, the SEP municipalities, and the stakeholders. The methodology of the project is based on some tools aiming at measuring the carbon footprint in schools, and it means that an automatic calculator accompanied by an operational guide addressed to the owners and managers of school buildings, a series of pre-established actions to reduce the environmental footprint, monitoring the effects of the activities carried out inside the schools, and the possible reduction of the footprint. The aim of the methodology was the elaboration and adoption of practices for the energy efficiency that were subsequently structured in school energy plans. And these school energy plans were afterwards put in synergy with the SEPs. So you see that the system is complete and it is a whole system. During the implementation of the activities, there was a continuous flow from the schools where some trainings or trainees were carried out through webinars addressed to the responsibles of the local training. Besides, there were some local training for those who locally implemented the activities in the pilot areas. And the local training covered the use of the calculator, how to create the plans to improve the energy efficiency of school buildings, considering both the direct and indirect consumption. The use of the calculator. The baseline school year was 2015-2016. There was also the identification of the hotspots and the realizations of the school energy plans, implementing possible initiatives and actions that could in some way reduce the energy consumptions inside the school buildings. And finally, there was the recalculation of the footprint using the same calculator and analyzing if there is a gap between the first calculation and the second one. The flow was, as I said before, from the schools to the territory, because the territory and especially the SEP municipalities were always involved in the progress. The initial meetings were organized in the headquarters of the municipalities, but afterwards we decided to put together the two works I mean, the municipalities and the school organizations. And as you can see in the photos, there were some meetings inside the schools. And there was a link between these different systems that usually do not speak together. And there was also the involvement of stakeholders through informative workshop about the project. They were realized at local, international, and national levels, the issue of newsletters explaining the progress and the deliverables and outputs of the project. Graphically, here is the final photo of EduFootprint outputs, where you can see what has been done during our project. But now we go deeply in the three tools that Pierluigi Porta showed at the beginning of the workshop. I mean, the EduFootprint calculator, that measures the consumption of resources and activities carried out in the educational organization and converts them in the environmental impact. It is a tool that can help managers and owners of schools and university building because they can identify the many environmental impacts of everyday activities and can the measurement is important because without any measurement, we cannot in some way place on the ground possible sustainable practices in order to reduce, in this case, the energy consumption. The EduFootprint calculator is based on a Microsoft Excel. And these are the data that have been collected during the project. There were 2 steps, I mean, maybe 3, because the first version of the calculator included all the parameters that you can see in the slide. But we realized that the school system is a bit different rather than a firm or a private organization. So it is important to take into consideration different aspects. So we decided to fine-tune the tool, and finally we arrived to a version 1 of the calculator that was used in order to collect the data dealing with the the baseline year 2015-16. After the implementation of the activities that and the initiatives in order to reduce those hotspots that were detected by the calculator, there was another collection of data. As you can see, is a very complex system of parameters, and considering also the presentation before that was before mine of Mr. Ricci, we took into considerations also other parameters such as degrees, days, the different climates of the schools in the seven countries, the state of conservation of the buildings. For example, in Albania was very difficult because there is no heating at all, and there is not the cooling at all. And so the collection of energy data was a bit difficult, and we had to adapt the tool to the different state country situations. The other tool, because we in order to link the calculator to the school systems such as students, teachers, administrative staff working in the schools, we decided to create a tool that could be easier and closer to them, and it is the app. The app is a sort of simplified version of the calculator. Is for Android mobile phones and can easily downloaded from Google Play. Here I leave also the link if you are interested in the app. All the schools that participated in the project have included their consumption, dealing especially with heating, electricity, paper, and mobility. These were the different types of consumptions that you can find in the app. And the third tool is the EduFootprint platform. The EduFootprint platform collects the best practices in the fields of energy management and reduction of the carbon footprint developed by the partners, and in this case, the schools. And they are categorized in 5 main topics, as you can see. So paper are the same of the app, paper, electric energy, thermal energy, mobility, and others. In this way, the schools can interact with each other and create possible synergies among them. The system is open and has been transferred to one of the project partners, represented a group of school. Our hope and idea is after the period of urgency caused by COVID-19 to continue and improve the tool. The platform also contains the access to the calculator and the list of help desk to contact in order to ask for information about the project and the tools and methodology experimented in the project. These are, yes, some sections that you can find in the platform. So there is a data school area is a closed system where the school can upload their experiences. Below there is a list of best practices that can be seen. This is the section of help desk, and as you can see, there is also, we decided to put also the EduFootprint calculator. So to create a complete system where it is possible to find all the tools, except for the app, obviously, and the deliverables that were created in the frame of the project. Which were the lessons we learned? Well, the main strengths are the great interest and involvement of a school community, the fact that exists, in any case, awareness on the environment preservation and the impact of our daily actions on the environment, a great support provided by the schools and the managers and owners that we were able to make owners, managers, and schools to speak together, and we could, in some way, to link all these activities in the local SEPs. Some municipalities were able to change, to modify their SEPs, including some templates dealing with the schools where the experimentation took place. Weaknesses, okay, lack of time. The project was very brief, and so we were not able to improve the data monitoring. Students are often involved in ordinary activities. Teachers are very busy. Administrative staff is often located in a different building, and technical interventions are often too expensive, or the buildings are too old. To fine-tune the model, partners have been warmly asked to promote the use of calculator, both for the pilot schools and for the new ones. But one point is important: to be very careful in the data collection. The collection needs to be very accurate, complete, and reproducible. So the more the measure is correct and method reproducible, the more the actions are beneficial and focused on the most important environmental phases. But EduFootprint did not end because it continued, and the EduFootprint Plus was awarded and was approved in the frame of the last call in the Interreg Med program. It started in March 2021 and is going to end in June 2022. The main aim of the new project is to enhance two tools. Enhance the capacity of public authorities to calculate the environmental footprint. There are givers and receivers. The givers will train and coach receivers to put in operation the EduFootprint products. The choice was on calculator and app. And the receivers will identify the significant impact areas of public building and plan effective allocation of resources to generate a positive impact. Okay, these are the tools that will be improved in the EduFootprint Plus. And I finish, maybe I was a bit hurried, but in any case, I'm here at your disposal for any question. Thank you very much.
Thank you, Valentina, for the very interesting presentation. There are not questions yet in the chat. I just wanted to know if you have any idea of how many times the app has been downloaded, or how many schools registered in the platform.
Yeah, this number is not. I don't know really at the moment, because there was also the problem of COVID, and this interrupted the experimentation. In any case, I agree with the Iriul of Slovenia, that is the coordinator of the new EduFootprint Plus. I asked him to be informed about the downloading process of both the calculator and the app.
Just another little bit question, just because you have the plus, the second part of the project. How do you think it's improvable, the tool? Where are you working to make this tool more efficient? Or
okay, this is a question that arises at the end of EduFootprint, because at the beginning, the province of Treviso is not involved in the EduFootprint Plus, but I know the reasoning that is at the beginning of the new project. The tool is flexible. I mean, we decided in EduFootprint to test it in the school buildings, but can be tested in any kind of building. In fact, the EduFootprint Plus is going to test in other types of buildings. So is very, very classic, and it can be improved very much. The problem is the experimentation, the monitoring, and the continuous use of the calculator.
Thank you very much.
You're welcome. No, we cannot hear you. Okay.
I closed the microphone. So now there's the not in program part. I will call Fabio Brescia from NAPS Lab. Is a part of the NAPS Lab. It's a technical assistant of the municipality of Barletta and lead partner of the project Effects that will talk about this project now.
Okay, thank you. Good morning to all. As Pierluigi already told you, my name is Fabio Brescia, and I'm the project manager. I'm a project manager of NAPS Lab, that is the technical assistance of Municipality of Barletta, that is the lead partner of the project Effects that I'm going to share. Can you see my presentation?
Yes, in full screen. Perfect.
Okay, perfect. So EFFECTS is the acronym of Effective Planning of Schools Buildings for Environment and Climate Changes. It is a project of Italy, Albania, Montenegro that is a smaller program of the MED one, but is always an Interreg, in which the territory involved are Puglia, that is our region, and Molise, and the whole territory of Albania and Montenegro. Our project is financed under the Priority Access 3, so environment protection, and our specific objective is to promote innovative practices and tools to reduce the carbon emission and to improve energy efficiency in the public sector. Okay, this is the framework in which we have developed this project. In particular, this project is led by the municipality of Barletta, that is in the north at the north of Baris province. The other Italian partners are municipality of Termoli and Enea. We have also the municipality of Vlora for Albania and the Ministry of Education for Montenegro. The partnership has been developed because all these partners, apart from Enea, are responsible for the management of some school buildings in their own territory. So the municipality for Italy and also for Albania, and the ministry for Montenegro. Enea will support the overall technical coordination of the activities due to, of course, its experience. This is a very fast project. We have just 1 year and a half. In fact, our project will finish at the end of February, on the next February. And our main output is the creation of some best practices in energy efficiency in school. What we want to do, we want to merge some technical and technological activities, for example, some solar panels or change lighting, so some traditional energy efficiency activities. We want to merge this one to some software activities. With software, we mean some activities that raise the awareness of some target groups. Which are these target groups? Are children and young people, so students. And this is the reason why we selected schools. Why? Because students are the future of us, so the next generations. So we think that working on the awareness of our next generation, we can create a virtuous cycle, and we can also in a way impact other target groups that are, for example, their grandpas, their grand, for example. So we merge, we want to, in a way, blend technological activities and software activities. This is the structure of the project. We are now at the first step of our project, so the work package T1 that relates to the assessment of the energy system. So we are now in a way study and analyze which is the state of art in the 3 countries that you can imagine, and some of the other relators already said are quite different. Very different. So the next step is the implementation of a pilot case that in a way will create a tool, a technological tool, a repository, but also through an energy auditing activity, also the design of some technological energy efficiency activities. And then we have another important part of our project, that is the last work package, dealing with the capacity building and the establishment of some, for example, living labs. So some activities that will act at soft skills level. So this is a very brief presentation. I have just 5 minutes, so sorry for this very quick presentation. I would like just to thank our partners, Enea Brindisi, for inviting us in this meeting, because it's very important. I saw some very interesting things also for our project. I think that we can capitalize a lot of works that the other colleagues have presented in their presentation. So I'm very happy and glad to be here.
Thank you, Fabio. I wanted to ask you if it can be some way to use the tools that we heard before in your project, but you already answered it to me, and I think, yeah, it might be a good opportunity for to mix the three projects. So if you stay, maybe we can have a small chat at the end after the next presentation, that is Mattia Ricci again, that will show us how the T-School tool works. And it's a pity that we don't have a part with Maria Matar as well with EduFootprint, but the time is this. So I leave the floor again to Mattia for the presentation of T-School tool.
Thank you. Share my screen. Okay, can you see it?
Yes.
Okay, so this is the website I talked you about before. improveyourschool.enea.it. In the left-hand side, you can see that there are the tools menu. Let's start, for example, with the energy profile module. Then some information regarding the school is need to be provided. For example, the school name, let's say Carducci. For example, primary school, state, Italy, and don't know, also Castel San Pietro, for example, the municipality. Here, the address, let me say this one, for example. Okay, then the consumptions are asked. Let's suppose that the heating plant works with natural gas. The consumption of the last 3 years. So, for example, 6,500 meters, and then this value and this. Then the software calculates the average value of the cubic meters consumption for the last 3 years. It is very important not to leave a zero in these fields, because of course it sums the values and it divides by 3. Then it is calculated also the kilowatt hour for the thermal energy and the CO2 emissions. You have the possibility to add different energy sources, for example, coal or firewood or whatever. Then going to electricity, we select, for example, one contract with the one company. I don't know, company energy service 1. Then the software asks for the kilowatt per hours consumption for the last 3 years again, and it calculates an average value and the CO2 equivalent emissions. Then some other data regarding the building are asked. For example, the volume, let's say about 2,000 cubic meters. Dissipating surfaces, and it calculates automatically the shape factor that is about 0.5. The gross floor area, let's say the sum of the heated surfaces for each floor, let's say, for example, 418 square meters. Operating time factor, it's a primary school, let's suppose 8 to 9 hours per day. The degree days are automatically computed based on the location we selected above. And this is the result. So you can say that in terms of heating energy, performance are sufficient but not satisfactory, and they are not satisfactory at all for the electricity consumption, for example. Here, the user has the possibility to download the document that summarizes the results of this analysis, as you can see. So it contains the same information, of course, we put in the software, but in a standard template. Then we have the possibility to go to the renovation module and to the economic module. If you go to the renovation option module, we have that a lot of fields have already been inherited from the previous module. So we don't have to put this data anymore. If we select directly from the tools menu the renovation option module without filling first the energy profile module, we of course have to put the data again. Let's suppose we want to perform, for example, an energy improvement acting on the glazing. Let's suppose we have to choose what type of glazing we have in the school. Let's suppose a single glass plus metal frame. Then we want to reach, we have the possibility to choose what level of energy performance of transmittance. Let me say we would like to reach sufficient, good, or excellent. Let's choose good. Then we have to put the area of the surface. For example, let's suppose to do the intervention on, I don't know, 10 windows, on 10 square meters of windows. Then we have the energy saving in kilowatt per hours, and the contribution, of course, is 100% because this is only one intervention. Let's suppose, for example, to renovate also the walls. We have now, for example, not insulated prefabricated concrete panels, 30 centimeters. We want to reach again a good level. We have 200 square meters of walls. Then we can see that the contribution of walls to the energy savings, to the total energy savings, is 91%, of course. We can perform the same considerations regarding, for example, the lights. Then we have to put the power before the renovation, after the renovation, and the working hours, and we can see the same information regarding the contribution. We have the possibility to download the document again, where the summary of this analysis and the renovation considerations has been reported. We have also the possibility to go to the economic module now, that has been filled automatically. We can download the spreadsheet, sorry, with some consideration regarding the economic parameters, of course. Here we can see the net present value of the investment done to retrofit the building. And then we have some information regarding the, let me say, the return time. Okay, here we can see that after 8 years, we have that the savings amount has been reached, the investment that has been performed. I think that this is all regarding the demonstration of the tool capabilities. And I think that this tool is very simple and very useful in order to understand quickly if our building, our school building, needs for a retrofit or not. Well, I think that's basically all. This tool is freely available, so you can connect to the website and try to play with it a little bit. The suggestion is to contribute to the spreading of this tool as much as possible. A possible improvement of the tool could be the implementation of a database where the user information that has been inserted in the tool are collected and can be analyzed, for example, for statistical considerations. So Pierre, for me, from my side, regarding the tool, it's really all.
Okay, got a question on the tool, because to put the information in the tool, you need a quite not a really basic background. Is there some? I know there's an e-learning part of the project.
Yes. Yes. So I share my screen again. The project, during the project, an e-learning course has been implemented that can be found here at e-learningcourse.enea.it, this one. Mm-hmm. This course is made up of open lessons, and it is think for municipal staff, professionals, student, energy manager. It is very useful in order to achieve a basic background on the thematic, on the topics of energy performance of school buildings.
And it's free.
And it's free, yeah.
Okay, thank you. So we have a lot of time, actually. If Valentina, I don't know if you have some prepared part for to show the tool that that you just introduced briefly, or if you want. If not, we can try to sum up with some consideration and go on.
I think that as it is going to be fine-tuned during the new project, I think that is not useful, in my opinion, to show you the.
No problem. So I'll ask to Mattia and Fabio to open the webcam and the microphone. Just we have seen 3 different projects with the same aim. It's the improvement of the efficiency of the school buildings. We saw different ways, tools that use that are intended for the decision makers, tools that are intended for the users, for students, and for the teachers. Do you think that this tool can help strongly in the improvement of the actual energy efficiency? Is something that can be done in short terms? Are there possibility to improve them in some way, or it's a long road?
I have 2 questions, one for Mattia and one for Fabio. The first to Mattia. We found difficult because we used the guideline as a sort of support in using the tool, but it was not so. We had, we had some problems in making use the tool, especially to the school staff, because professionals are more used to this type of reasoning and technical approach. But as regards the students, the measurement, as I said before, is not very common among students, teachers, but sometimes also among municipal staff. I'd like to know if you found the same, you are finding the same problem in your project. And after I asked to Fabio a question regarding Living Lab, but
no, we actually did not found this kind of problem right now, but I think that if you have, it is important to, if you can, to communicate us what kind of problems arise, because we can perform some improvement actions on it.
Okay, okay. Thank you very much. Thank you.
Thank you.
And Fabio, maybe I didn't catch some points because I was writing something. As regards the Living Lab model, because we have a Living Lab that is Green School, so we know the system. And I'd like to know how you are including this model in your project.
Okay, first of all, this is something that we are still designing. So
okay.
There's no Living Lab already established at the moment, but in general, in our project, we thought to these Living Labs as another tool. It is not a technological tool.
No.
It is, of course, it is an in-person tool in which, and these Living Labs will be established inside the schools. So not in the municipalities, but in the schools. This in order to catch better our target groups that are young students. So we will dedicate a specific space inside the school in which we can show and in which we can have some meetings, in which we can raise the awareness of young students about the energy efficiency. So their behavior also towards the energy efficiency.
Yeah, because usually the Living Lab is a sort of a co-working process, and we are including in our Living Lab both the school organization, but also the stakeholders and all. And it's hard to make them work together, but in any case, the results are very interesting, and also the use of a competition among schools is very interesting. In the EduFootprint, we made a brief guidelines for the competition, but as we have a provincial project that is funded directly by the administration, where every year we put the schools in competition, and the aim is the reduction of the energy consumption. That is energy, light, not heating. Heating is a bit different to collect the data, but and the awareness is in the behavioral aspect is very important in reducing the gap that and is in percentage is very interesting. We found very interesting the behavioral attitudes of the students.
I think exactly. We would like to work exactly at that level.
Yeah.
We have technicians, we have energy auditors, so they can act at technological level, but there is also the behavioral attitude, as you told, that is very, very important on the use of the technology.
Yeah, also because technologies can be updated, you know. I mean, is not there is a lack of economic resources. at the basis, but also is a continuous progress of technological solutions. So the behaviors is what you can go on working, and it's interesting. Yes.
I think we have the instrument for the calculation to improve the energy efficiency, but what we have to work on is the behavior for students, for the user actually. That they are the important part in the school use, and both in administration and decision making, that make aware that there is a problem and there are solutions already existing, but they have to apply it to solve the problem, because as we know, it's a huge amount of energy use and emission due to the public buildings use phase actually. I think that we almost finished the themes. Do you want to? I don't know, Fabio, if you want to, if you have some workshops or something, some presentation close of your project in the next period, or some events that you want to promote now.
I don't have events, but I'm happy that you asked about this, because we are finishing, as I told you, we are finishing the first step, the analysis, the first phase of the project that deals with the analysis. So after the summer, also because schools are open at the end of September, we will start our pilot activities that is okay, technological, but is also with events and with workshops. So if you want, all of you want, we will share with you the invitation for these workshops.
Yeah, might be a quick presentation of the two tools as well in your workshop.
Yeah, thank you.
So to the audience, I will ask to fill please the survey that you find in the chat. It's a really brief one, and I hope it's been as interesting for me as for all of you participating. And we finished we have been good. Often we have the longer presentation. Now we finish in half an hour before, but I think the presentation have been interesting for all of you. I thank you a lot for participating, and I hope to meet you sometime somewhere physically, hopefully. Thank you.
Thank you very much. Thank you.
Bye.
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 Bye. Bye.
Thank you all. Bye.